Let's recall that if we go from a displacement to a velocity to an acceleration, this is the process of differentiation. If we go the other way, this is anti-differentiation. In fact, in the example we do now, we're going to start with information about the acceleration and deduce something about both the velocities and the displacement. So we're going to assume what's called uniformly accelerated motion, namely that the acceleration at any given time is constant, and in fact, we'll denote it as minus g, where g here stands for the acceleration due to gravity. In other words, we're going to be thinking of a ball that's falling under the force of gravity and accelerating at that uniform rate. The derivative of the velocity, which recall is the same as the acceleration, is equal to minus g. From that, we can deduce something about the velocity itself. Now, let's think for a minute. What sort of function did we have to start off with in order that when we differentiate it, we get minus g? Well, clearly it should be something of the form minus g times t, because of course when we differentiate this, we'll get simply this coefficient minus g. In fact, there could be any other additive constant, because the derivative of that constant would vanish when we differentiate. Now, what does this constant mean? Let's look at the fact that if we plug in t equals 0, we get v of 0 equal to c, and so therefore c is actually denoting the initial velocity of the object. That initial velocity could be positive or negative. In our case, perhaps the ball is moving upwards. Let's see what happens as a result. Okay, now from the velocity, we can say something about the displacement. So let's recall, first of all, that the derivative of the displacement is the same as the velocity, and therefore we can say something about the displacement itself by finding a function whose derivative is this quantity. Now, in order to be able to get this, when we differentiate the displacement, we have to have one higher power for the variable. So when we differentiate t squared, we'll get the power t to the 1. But we'll also get a factor of 2 that comes out. To account for that, we're going to divide this by 2. And so altogether, we'll have minus g over 2 t squared, remembering that now this is v0. The second part, we'll need the function v0t in order to give us this. And finally, we may have another constant k that appears here, which again, when differentiated, vanishes to give us the velocity. About this constant, we could say the following. If we look at the displacement at time 0, these two terms vanish, and we're left with y at time 0 equals k. We're going to denote that by the quantity y0 for initial displacement. So altogether, we've been able to figure out both the velocity and the displacement.